it is developed the environment for statistical computing and graphics. So what are the statistical terms we are going to do in our manually? We are going to do that computing all the statistics data through our computer system. For that, we need a tool. That tool is statistical software tool. The statistical analysis, the SAS already available in our the computer world, a statistical analysis system design tool. So that tool we are going to buy means we need to give a subscription. You need to buy the subscription. We have to do the subscription day by day whenever we are going to do that the statistical computing analysis. So for create it is for freely available. It is open source available software. And Robert Gentleman at the University of Auckland, they were founded ones of programming language, or that is R is a completely interactive programming language. It is also an object-oriented programming language that is designed by statisticians and for data analysts for doing some research works. Next, origin of R. So where this R was developed in this year, 1990s. The R is originated at the University of Auckland, New Zealand in the early 1990s. Karthik sir, next slide, sir. So the early of 1990s, the role Ikaka and Robert Gentleman were looking for a statistical environment to use their teaching lab. The first version of R was released in the public in June 1995. The development environment we can freely download that. This is R environment in that it is a distributed. It is in the distributed form. The internet side of SRAN. So comprehensive R archive network. From this network, we can download the R freely available. R is a open source programming language. We can download freely in our internet environment by the site name is at www.sran.or.project.org. Here we can download this. Or else another website is www.r-project.org. So from this we can download the R. So whenever we are going to use this JAMOVI tool, we must need that R programming language should be installed in our computer systems. The next slide, sir. So why we are going to use this R? So I told you that is first one, it is the open source software. Second thing, for doing statistical computing, we must need R programming language. So and also it supports multiple platforms. It can run on any operating systems, Windows, Macintosh, Linux, everything. So it has excellent built-in help systems. It has excellent graphical capabilities. So we can generate the graph for our analysis. Any type of graph we can generate for doing our research works. Then it is a powerful and easy to learn syntax. The syntax is very low. So many built-in statistical and mathematical functions, that is, libraries are there inside this R. That is over 18,000 different packages of libraries is available. Main thing it's useful for statistician, data scientists, and research scholars. So as a research scholars, this will be very much helpful for analyzing on our existing system, our proposed systems, and existing data and our proposed data, and what is the differences, what are the covariances. We can do the variance, everything, loga, classical loga, we will see one by one how we can do for our research works. Okay. So next slide. So next, the main thing we are going to see about this today, FDP, is the tool is JAMOVI. JAMOVI is a tool for, it is an open source software tool for doing statistical computing. This is statistical software. This is a replacement of the commercial software SAS and PAS. So SAS was very commercial. It was when you want to subscribe our SAS for our university, we can give that crores of lakhs of amounts to subscribe and do the statistical works for doing statistical computing. So here, why we prepared the JAMOVI. So the JAMOVI is freely open source. It's freely available for the people who are doing analytical, statistical analysis, data analysis, and research analysis and research methodology. Those who are doing that. So JAMOVI is freely available. Okay, we can download this JAMOVI freely from the internet. So how we are going to, I'll show you how to install the JAMOVI and how to download and install the JAMOVI, and I'll tell you how to after that, by using these tools, we can do the computational statistical computing. You will see. So before going to download the two things, what is that JAMOVI and R programming environment, I just want to give some introduction about what is JAMOVI, what is the JAMOVI panel look like, what are the things we are going to do in a JAMOVI. I'll give some brief intro on the JAMOVI. After that, I'll show you how to download this R programming from this internet and how to install and how to download this JAMOVI tool from this JAMOVI environment and how to install for the different operating systems. So what is the JAMOVI? JAMOVI is a third generation statistical spreadsheet. So it is it's like a Microsoft Excel sheet, that is a spreadsheet. So why I am saying it is a third generation, it is a third generation to that Microsoft Excel sheet. Okay. I said it is an open source statistical platform. If you want to, this software is built by, that is developed by the programming language R. So whenever you want to use JAMOVI on your computer systems, you must install R on your computer system. That's why, see the third point for this JAMOVI. So it is built on top of R statistical language. So it is an alternative to commercial statistical software SaaS. So for buying the lakhs of amount of spending the lakhs of amount, we can freely use this JAMOVI from this JAMOVI environment. Okay, so it supports multiple platforms. It's run on any OSs, Windows, Mac OS, Linux, Chrome OS, anything on any OSs, a JAMOVI can be run. Okay, next. So how the JAMOVI tool is look like. So it has a navigation for once you kindly see this slide. It has menu bar. The three horizontal lines represents the menu bar. It has a variables, then data, then we can do the analysis, that is research analysis, data analysis, and statistical analysis. These things, these are the main things we are going to do on this JAMOVI tool. Then we can edit the data. Okay. So we can plot that exploration. First that the graph shows this exploration shows that we can generate the graph and we can do the tests like t-test, ANOVA test, and regressions, linear regressions, correlation. We can find the correlation coefficient, frequencies, the factors diagrams. Then everything we can do this on this tool. So then the right end there is a plus, that is the symbol shows the models. We can import that different packages or models into our JAMOVI tool. We can use this model, we can working on that. So we have a variable tab for handling the variables and their type. So maybe variable may be a continuous variable or a discrete variable, anything we can have. And the data tab handles variables, different variable we can handle. So it has analysis tab. I told you that analytical data statistical analysis tools, the t-test, ANOVA test, and regression, frequencies, and factors. So it has additional options and models too. Next slide. So next. So menu. See, this is the panel view of menu of JAMOVI. We can create a new project by clicking on the new. We can open the existing project, existing document, or existing spreadsheet which will be installed in our computer systems. We can save our JAMOVI file. So for saving this file of JAMOVI documents as .omv, the extension of saving, kindly note how to save this JAMOVI file on your computer system. The extension is saving the file with the file name, any file name you can give. For example, I'm going to do with medical data .omv. This OMV is extension for saving this JAMOVI file. So you can export the another file into your computer. So for example, seeing this slide, we have that some computing means of .omv, binary logistic regression.omv, variable entry.omv, mancova.omv, and ANOVA.omv. So these are the files we are saved in my computer systems. The extension is .omv. So this is the main thing. We are going to save our file with the extension is .omv. Like our Microsoft document, we are doing .doc, Excel is .xsl. So similarly, for saving the extension of a JAMOVI file is .omv. This .omv is represent the JAMOVI files extensions. So next slide. So next is the second option while clicking on the open button. So this PC it opens the various data files. So already I have stored some different data sets on my local disk. That local disk can be opened on your computer system by clicking on the open menu. That is open under the menu. I can click on the open option. This PC represents my local disk, my local PC. So I can work by clicking on the browse. I can open all this analysis, the files, data sets, images, whatever I want, what are the things, what are the files I want to working on my JAMOVI tool. I can open through this open menu. Next is it. Next is open a data library. So you open the data library already you have installed on your computer systems or you can store in your computer systems. The data sets from various data models you can open. So second option of open is next is a data library. So for example, I have a general analysis for linear models in JAMOVI that I have already stored in my computer systems. That data library I can install. So advanced meditation models, the wrapper for some G-stats plot, and some these are the folders I have already have. Then for next is I can open the data sets. See this tooth growth data sets I have. I have bugs in my data sets. I have big five Dolan and all stolen. These are my example data sets I have already saved in my computer. This data sets can be opened on to my through the compute through this data library option. So next is next is variables tabs. So variables tab is that attributes data what you are stored in your spreadsheet. That is the column name of your data sets. They are called it as a variable. That variable you can create. Say for by default, when you are opening the spreadsheet, it comes with that A, B, C. So you can rename this A with for example, I'm going to enter the name of the patient. So patient name, I can give A as a patient name. So B as the age of the patient. C as a disease is that's affected. So these are the attributes you can rename this ABC. Whenever by default this ABC will be out by default it will be open. You can add any number of variables into your JAMOVI tab. You can rename this attributes. Then you can set the data type and measure of the data. What is your data you're going to handle? For example, a name. Name is a general, it is a string. You can set this a name is a string data type. So age is a numeric data set. So you can, if you want to working on these data sets for the analysis, you must show inform to the JAMOVI tool. This data is a type is character. This data type is this attributes type is integer. So this is the way you should communicate with your JAMOVI tool for doing analysis. So here you can do that. You can edit a variable, you can compute a variable, you can transform a variable, you can add and delete a variable. So as like Microsoft Excel, here also we can do the filter options on that variables. Okay. So for example, I want to compute. Compute is nothing, but I'm going to compute a new variable. For example, I have variable height. Okay. I have another variable weight. So by using this height and weight, I can able to create another new variable. I can compute the another variable that is BMI, body mass index. By dividing the weight divided by height, I can calculate this body mass index. That's why here is the another option. There is a new, you can compute a new variable from the existing variable. Okay, that's a second one is compute. Then transform, you can transform one type of variable into another type of variable. So these are the variable tabs you can do this. So before we are going to see this, the entire tool. Before that, we must know about what is the basic statistics, what is a variable, how to compute a variable, how to define the variable, everything we should know that. Okay. So next slide. So variable tabs. So next, you can insert, append, and the data variables, the computer variables, and data variables. So you can by right click on this the panel. You can insert a new variable. You can append a variable. You can compute a variable. You can transform the variable. So while clicking on the variable, by clicking, for example, I want to rename this variable A. That is, I'm going to change this A as a age means. While double clicking on the A, the new panel, that is, new dialog box will be open on your JAMOVI tool. It will source this, what is the variable name, what is the measure type of the variable, what is the data type of the variable. So to know about this, what is the measure type, what is the data type? The measure type is a statistical term. We will see the later in the next session how the same in this session. What is nominal? It has four types: nominal, ordinal, categorical. That is divided into nominal and ordinal. Then interval and ratio. These are the four types of measure type we should classify our data. We will see one by one what is nominal, what is ordinal, what is interval, what is a ratio, everything. So next, data type. We know the data types already. We know the data concepts of data type. What is the type of the data? What is the data represents? It may be an integer, it may be a character, it may be a string, it may be a double, it is maybe a floating point, everything we can. So if you want to add the next variable, you can move from variable. You want to hide this variable means by using the hide option, you can hide this variable. So in Microsoft Excel, we can hide this variable, right? That is attribute. Similarly, here also we can hide the variable. We want to move from one variable to another variable by clicking on the next variable option. You can just clicking on the next variable, you can go with B, that rename the variable, go with C. Then finally, by clicking on the plus add, you can add some variable values to that variable. So for example, if you want to change this, you want to give the option for a variable. For example, you have clicking, you are generating the attributes as gender. You can give the option for the choosing the variable as a male, a female, transgender. This is the option you can give by this. By giving option is that levels you can set in the variable tab. Next is a data tab. The data tab is nothing but the fields of this spreadsheet. You can see this. So data type tab is that is a field. For example, see this A is age, B is a name, so C is a disease, everything affected. I am computing the medical data. So here, what are the things I can do that are like the same thing what we have do in Microsoft Excel, that all the data options we can do them. We can copy and cut paste. We can set up, we can compute the transform, same what is the options we are doing the variables. You can compute the variable, transform the variable, add and delete the variable. We can apply the filters and add and delete on this data tab variables. One second. The next is data setup in JAMOVI. How do we set the data setups in JAMOVI? I said already. I said so. First, you have to declare the variable name as. So, for example, I am to give set my variable A as age. Okay, I am describing that the age of the patient. And description you can give this is the age of the patient. The measure type I told you, it has four types. a nominal, ordinal, the interval, and ratio. Okay. So the nominal ordinal is a categorical variable. I'll say I will demonstrate how we classify the data as a nominal data, it's ordinal data, and what is the continuous data and what is the ID. The data type. So we can specify the text as a string. So string date, for example, name of the patient, that is a text. So age of the patient, that is an integer. So, for example, the fees paid for this checkup, that is a decimal. So, this is the way you can set the data type of the variables. So, you can add that variable, you can move the one variable to the next variable, by the next tab, you can hide the variable. Next slide, sir. So, the measure type, you can set this the nominal data. To look like that is a Venn diagram symbol is a nominal. The bar chart symbol represents the ordinal. A continuous variables represent the scales. The IDs represents that. It is a discrete variable. That is a ratio variables what you are doing. So data types. These are the basic data types which already present in the JAMOVI. Integer. That is, it represents the whole number. A decimal like a floating point variables, floating point values. Then text shows that the string of string data type. Okay. This is the way you can set the variable for your data type. So I'll demonstrate all the hands-ons in the next session, how you can set all these things on this JAMOVI tool. Next slide, sir. So that is the analysis tab. I told you the next is analysis tab. That is a data analysis. So these are the main analysis we are going to study in this FDP. So exploration as representing our data into a graphical normal analysis. That is, we have to find the statistical terms, mean, median, mode, variance, covariance. You have to find that exploration. You can draw the graph of bar chart, bar graph, everything you have to do. Then we have to do the T test. It is a statistical term. Then ANOVA, one-way ANOVA and two-way ANOVA. Then regressions and frequencies and factors. These are the things we are going to do that in the analysis tab. By clicking on this each tab, we can computing the variables. We can selecting on the variables. We can do the analysis. We can do the test on this analysis tab. We can models represent. If you want to do add any other add-on model to your JAMOVI tool, you can just click on this plus button. You can do that add-on model on your JAMOVI. So the first one is exploration. It has, when clicking on the exploration, you can do the two types of statistics. Descriptive statistics, that is, it has the scatter plot and Pareto plot chart. You can do that. You can by clicking on the exploration. Okay. The next, so edit tab. Next, you are clicking on the edit tab. You can after the menu, next tab is edit tab. The edit tab, you can have a like you can do that copy and cut. You can do undo. You can change the font style. We can set the paragraph alignment, list indent, you have to do that. Then you can insert the formula here. This is the main thing. Like in, for example, I told you we can compute a new variable from the another variable. Okay. So already I said the example from this variable of height and weight, I can able to compute the body mass index from this variable. So I can take this height as a one variable name and weight as a one variable name, HW by V. I am going to create the body mass index BMI equal to. So I can apply the formula. I can write the formula for calculating the body mass index. I can then computing another variable, that is this FX formula it shows for computing the new variable. That is a formula bar will be there. By clicking on that, you can insert the formula on your data sheet. You can compute a new variable from the existing variables. Then you can apply the styles, the code black, heading, and link. What are the things we have to do on Microsoft Word and Microsoft Excel? Everything we can do on this JAMOVI tools also. That is a edit tab. Next is so installation of add-on models. So I told you add-on models. If this some of these models does not will be not available in your current JAMOVI systems, you can add these models. You can download these models while from the internet, from the JAMOVI library. You can download that model. You can install that model on your program. So for installing this add-on models, you can click on the analysis tab on the right side. You can click on the model icon, that is a plus. Then you can click on the JAMOVI library. From this library, which are the models is available? This list shows that. Sir, next slide, sir. Karthik, sir, next slide, sir. Okay, sir, thank you. So once again, repeat. So if you want to install the add-on models on the JAMOVI tool, you just click on the analysis tab. From the right side corner, there is a models plus button in there. If you want to, this plus button represents, you want to add on models to your JAMOVI, that you can click on that plus. Then it has to be listed out this JAMOVI library, under the JAMOVI library. For example, JMP, scatter, the JStat dot JPower. So these are the built-in models. If you want to use these models for your analysis, you can just click and install these models on the JAMOVI. After that scatter, for example, you want to install scatter on your JAMOVI means, see this is the tab of tabs, variables, data analysis, edit. The next is the edit to that, the scatter will be appear on this menus. Okay, this tab. So by clicking on the scatter, you can do that operations on the JAMOVI. This is the way you can do that add-on models on your computer. For example, I'm going to click on available tab. So next slide, sir. So when you click on the available tabs, what are the things available? For example, I'm going to install the RJ editor on to run R code inside the JAMOVI. For example, I want to run the R code inside the JAMOVI. I need a modern model. So I just click on the RJ editor to run R code install JAMOVI. I click just install button. So this model will be installed on my JAMOVI. Then next slide, sir. It will be shown on my the tab menu. The tab menu is the tab menu will be shown. Karthik sir, kindly check your mail, sir. Can you share the PPT shared with you?
Okay, sir, I will check.
Okay, sir. Kindly share this PPT.
Sir, is it visible, sir?
Yeah, sir, visible, sir. Thank you. One second. Okay, participants, before we are going to do that statistical computing, this JAMOVI tool, we must know the basic concepts of statistics. So without knowing the basic concept of statistics, there's no use of understanding the JAMOVI tool. We can't able to do that computing process on the JAMOVI. Okay, sir. Next slide, sir. So here we are going to see about this. What is data? We are going to see about what is the data. Then what are the types of data we have to classify or data sets. Then what are the level of measurement? And this previous answer, previous JAMOVI explanation, I have just given the measurements. There is nominal, ordinal, categorical. That is categorical is related to nominal and ordinal, and intervals and ratio. Then we'll see this, what are the types of statistics, which summary statistics we have to use, and what is the types of chart, what is the which chart you have to use for our research methodologies and data analysis. So next slide. So this is our data. We have to show our data as a graphical method. So next slide. So graphical representation of your data may be a graph, maybe the displays or chart by chart, everything display system or a pad or a list of the data we can show. So our data, so data is nothing but it is a collection of information, okay, from which the conclusion may be drawn. So maybe our data may be a quantitative data, or it may be information, or it may be a graph, or it may be a measurement, or maybe observations, or maybe a facts or numbers or anything. So mostly our research data should be comes within these items. Maybe a quantitative data, maybe a information, maybe a graph. So we can do the measurements on our research works. We can do some observation from the existing works, our current work, the facts and numbers. We can be working on this data. So we must understand these are the terms or data. Next. So again, I have classified our data into two types. I told you that is a qualitative data and quantitative data. So qualitative data is nothing but the characteristics being studied in non-numeric. The non-numeric data are qualitative data. The quantitative data are the data can be counted. That is a numeric data that is called as quantitative. For example, non-numeric data are gender, male, female, and transgender. That is a qualitative data. It does not, we can don't have quantitative data. So religious affiliations, Hindu, Muslim, Christian, Buddhist. So these are the religious data. So state of birth, the person's birth in India. So where he is birth, the Tamil Nadu, Karnataka, Andhra, Uttar Pradesh. So it's the presence that non-numeric data. So condition of the patient, he is a very weak or low, he is a good like that. So words, the images, the videos, these data are some example data are qualitative data. Quantitative data is nothing but there is numeric data. So this characteristics being studied as a numeric. Okay. So times in seconds for 400 meters of age. So age of corona patient and number of white blood cell in the blood samples. So these data are called as quantitative data. So we must know the difference between what is the types of data. That is the two types, quantitative and qualitative. So qualitative is sir, next slide, sir. Okay, sir. So quantitative data is again classified into two types, discrete variable and continuous variable. So discrete variable, as we know that is exact count we can give that the data variable values is called as a discrete variable. So number of visits made by the doctor. For example, today the doctor is going to be visiting 100 patients. We simply give the discrete variable value as 100. The number of goals in the football match. He put this team put 10 achieves 10 goals. So we can say that the number of goals in football matches at 10. The number of wickets by the cricket bowlers in the cricket matches. We got it 6 wickets. So we can say it is a discrete. We can encounter the whole values of the data. That is called as discrete variables. So continuous variables means that can assume any values within the specific range. For example, height of an athlete or weight of an boxer. So athletics team, maybe the height may vary from 5.11 to 6.6. So this is the range we can give it. The range of data values we can give this. We can give means the data is called as a continuous variable values. So discrete variables means the exact value of the data we can give means that is the discrete variable. So we must know before going to the statistical analysis, first we classify our data. First you classify our data into two types, quantitative and qualitative. While your quantitative data is classified into discrete and continuous. So the counting data, again, the numeric data is again classified into two types, the continuous variables and discrete variables. So continuous represents that is a range of variables. And discrete variables means the exact count of the value you can give for the certain attribute that is called as a discrete variable. Next slide, sir. So see this graph, this chart, the types of variables is classified into two types, quantitative and quantitative. So qualitative data is non-numeric. Qualitative data is numeric. Again, this numeric data is classified into two types, discrete data and continuous data. Discrete is children in the family. So 3 children in the family. The exact count I can give, that is a discrete data. Stokes often a gold fold, that is 10 folds. So TV sets one, she has 3 TV sets. So continuous means amount of income tax paid. So in this organization, we have to pay the income tax from this range from 15,000 to 2 lakhs. So this is the range. So weight of a student in a class. So in my class, the weight of the students is vary from 60 kg to 75 kg. So this is the range. So when a rainfall, yearly rainfall in any country, its range is from. So this millimeter to this centimeter of range that we can have. So by giving the ranges, that data is called as continuous data. And giving exact value of a data, that is called it as a discrete data. So again, the second one is first we saw on that. So next slide, sir. We saw on that what is that types of data. The data is data types we have saw. Now we are going to see about level of measurement. How to measure the data's levels. Okay. So again, this has two types: categorical and scale. So categorical is classified into nominal category, nominal type and ordinal type. So for doing statistical analysis in a JAMOVI, we must set that measure types and data types for the data. So for setting the measure levels of measurement, we should know what is nominal, what is ordinal. So for the scaling type, what is the interval, what is the ratio we should know. So first we are going to see about the nominal. So next slide. So nominal level data means a qualitative variable data can be classified as counted. This is a qualified data. That is qualitative data. So I told you there is a two types of data, qualitative and quantitative. Quantitative only different classified into discrete and continuous. Here, your qualitative data is classified into nominal and ordinal. So observation of qualitative variable can be used to be classified and counted. For example, gender. I can classify my gender as a male, female, and transgender. Okay. So male is how many number of male I can count it, how many number of female I can count it, how many number of transgenders I can count it. So this type of data you can set the data as nominal data. For example, gender. So blood group, you can have a blood group A positive, B positive, O positive, AB positive. So A negative, B negative, B negative, O negative. See this graph. This type of this is classified. So 24% of the people having A group. So 31% of the people having a B group. The 6% of people having a AB group. Then 0%, 39% of the people having a O group. So nominal data is nothing but your data can be qualitative variable. That is your observation is qualitative variable. That is be classified and counted. So blood group is classified as A group, B group, AB group, and O group, and counted. Similarly, the gender is classified male, female, and transgender. It is classified and counted. Okay. So there is no particular order to the labels. It is true for the two operators, whether equal or not equal, whether the person is female or not female. So it is only true for the two operands, equal or not equal. For example, blood group, so marital status, then eye colors and gender and religion, then favorite beverage, for example, milk, tea, coffee, cold drinking, and nothing. So you can classify your data and counted your data. These type of data is called it as nominal data. So next slide, sir. Next is ordinal level data. So your data classifications are represented by the ranges. So this is the label names. Of counted, it is ranked in order. Okay. Now, for example, the stages of disease of a person, of this person, for example, with the disease has a very low disease. He is affected with the disease. Okay, you can classify your data as the ordered and ranked. See this pictorial like presentation of this ordinal data explanation. We can classify the chili as hot chili, the hotter chili, and hottest chili. Okay, so this is the way you can classify your data as low, medium, and high. So this is the way you can able to classify any data. That type of data is called as ordinal data. These data is only true for the operators equal, not equal, greater, greater, not equal, less, less, not equal. So the examples of the stages of disease, the severity of pain, the level of stratification, so Likert scale. So these are the Likert scale. The range varies, the low to high. So you can order and rank these type of data is called as ordinal data. So once again, I repeat, the categorical data is classified into two types: nominal data and ordinal data. So nominal data can be classified and counted. So ordinal data can be classified and ranked and ordered. These type of data is called as ordinal data. So these are the examples of this data's classification as nominal and ordinal. The next one is classical. It has two types: interval and ratio. So next slide, sir. So interval and ratio. So the interval range from here to this, for example, the size of the shirts in Indian, that is the size shirt is vary from 8 to 44. So this is the range. So the data classification was ordered and according to the amount of the characteristics they possess. For example, the children can have a shirt size is 8. An adult can have the shirt size is 30. So similarly, you can classify your data and order the data based on the amount of the characteristics they possess. The equal differences in the characteristics are represented with the equal differences in the measurements. So it is the true for the operators, all the things: equal, not equal, less than, not equal, greater than, not equal, plus and minus. So temperature, we can classify the temperature during summer days and the rainy days and winter days. And SAT score, the shoe size or dress size, so distance from the landmark, geographical coordinates, the longitude and longitude. So this is, for example, the dress sizes vary from 8 to 28, the burst in 32 to 52, waist in 24 to 44, hips in 35 to 55. If it is a 8 means we can have the burst is 32, waist is 24, hips is 35. For the fan size is 8. Okay. So similarly, you can do that intervals of data, that is a scale data. It's an interval level. This data classification is interval level data. The data can be classified and ordered according to the amount of characteristics they possess. That is called it as interval data. The next slide, sir. Ratio level data. So ratio level data is here is nothing but the data classifications are ordered according to the amount of characteristics they possess. How much of characteristics they possess based on this. I already told you, by calculating the body mass index, we can find out the height, and by the weight, you can find the ratio. So height and weight ratio, you can do that. So data classifications are ordered according to the amount of characteristics they possess. So equal differences in the characteristics are presented with the equal difference in the numbers assigned to the classifications. 0 point is the options of the characteristics. So and the ratio between the two numbers is meaningful. The ratio between the two numbers is 0 means there is options of characteristics. So the height and weight should be in the ratio level. The ratio level of data is called as this is scale data. So it is true for the same on the operators: equal, not equal, less than, not equal, greater than, not equal, plus minus. Additionally, it is true for this addition and multiplication. Sorry, multiplication and division. So, for example, examples of head circumference of the person who is present in my class. So that is a ratio level. So time to until the death. So weight, Kelvin temperature, height. These are this data or a ratio level data. So height and weight are ratio level. So this type of a weight person having the height is level. So we can classify the levels of data as a ratio level. This type of data is a ratio level data. Once again, I have concluded this. Next slide, sir. So the levels of measurement has 4 types: nominal, ordinal, interval, and ratio data. So nominal is nothing but your data can be classified and counted. Ordinal means data can be classified and it should be ordered and ranked. Interval means that if the measurements but do not have a true zero. The difference between the measurements true zero exists. So examples we see already, the nominal data is a gender, ordinal data is the quality student letter grades. That is, he got a grades from A to H. Okay. So interval data, the temperature, and the ratio data is height, weight, and age, and Kelvin temperature. These are the data. So these we should know the difference between how to classify the data. The two types, qualitative and quantitative. So qualitative data are again classified into nominal and categorical and scale. That categorical data is classified into two types, nominal and ordinal. The scale data is classified into two types, interval and ratio data. Again, the quantitative data is classified into two types, discrete and continuous. So discrete variables means exact values we can give for the variable that is a discrete. The next is what is that? Range of values we can give that for the data values that is called as continuous variables. So this is the chart represents. Next slide, sir. Level of measurements. So level of measurements, nominal, ordinal, interval, and ratio. So this chart represents. So for nominal means data may only be classified. So ordinal data are ranked. So interval, a meaningful difference between the values. So meaningful 0 point and ratio between the values. So say there's the examples that possess for the different types of character data. So next we have to the next slide, sir. We can decide the level of measurements. So age, mother's age in years. Okay. Then we can see weight of the infant at the time of birth. The third question is religion. Father's religion. There is a Hindu, 1 represent Hindu, 2 represent Muslim, 3 represent Christian, 4 is others. Smoking status, whether he is a smoker or non-smoker. So labor pain, low, medium, severe. So history of hypertension, 0 or S. So number of physician visit during the hospitalization. So program feedback, very bad, bad, neutral, good, very good. So here that the data can be classified and ranged. That is program feedback. So see this next slides. You can understand the level of measurements. A mother age, that is the interval. So for example, a mother's range is in the range of 26 to 36. So this is the range of the mothers while they become a mother. So mother's age is interval. So weight of the infant, that is a interval. So father's religion, that is a nominal. That is a religion can be classified and counted. Smoking status also, whether it is classified and counted. Smokers and non-smokers, that is a nominal. So labor pain, that is ordinal. It will be ranges, low pain, medium pain, and high pain. That is, I said it is a ordinal data. So hypertension, history of hypertension is also a nominal. A number of physician visits is the interval. So during this time, how many number of physicians visited the patients? So program feedback, that is ordinal. So we can give that for this FDP, we can give the feedback as we can give that feedback level maybe low, medium, and high. Good, very good, bad, like this. So this type of data is classified as ordinal. So we should know that how to give the measurements of the given data sets. We first know that. Okay. The next is the next slide. Next slide, sir. Next slide. The level of measurement of why to know the level of measurement? To decide the suitable summary statistics. Why we should know the level of measurement means first we should decide the suitable summary statistics. So summary statistics I already told you, t-test, ANOVA, classical ANOVA, regression, which type of summary statistics we should choose. So do that appropriately, present the data. If we can present the data appropriately, determine proper statistical test. Which statistical test we have to do? So for Doing the statistical analysis, we should measure our data, whether it is a nominal or ordinal, or it is interval data, or it is a ratio level data. So for the three things we should know: decide the suitable summary statistics, which statistics we are going to use. Second one is appropriately present our data. The third one is so determine the proper statistical test. So next slide. Next is we are going to do the types of statistics. So the type of analysis, the type of statistics is classified into two types: descriptive statistics and inferential statistics. So descriptive statistics is nothing but if you take any data set, you can do that statistical computing to the entire data. To the entire data. For example, I have 100 number of students or 100 number of patients from the hospital I can take for doing some research on some disease means I can do that statistical computing on the every hundreds of patients means that type of statistics called it as descriptive statistics. Okay. Inferential statistics is nothing but I can take hundreds of patients of data. From this 100, randomly I can select only the 20 number of patients. I can do the test, do the computational statistical computing on this only the 20 data from the 100. That statistic is called it as inferential statistics. These are the two major difference of two types of statistics: descriptive statistics and inferential statistics. Descriptive statistics nothing but you can do the statistical computing the entire data. For example, I have hundreds of patients I can have for doing research on some disease. I can do the statistical computing the entire hundreds of patients means that type of statistics is descriptive. Inferential means I can take some samples from this 100. I can do the research. For example, I can take 30 samples from the 100. I can do the statistic computing on this 30 only. That type of statistics call it as inferential statistics. So presenting, organizing, and summarizing the entire data, that is called it as descriptive statistics. Inferential statistics nothing but so drawing a conclusion about a population based on data observed in the samples. We can take a samples. From the sample, we can do the statistical computing analysis. Then we can present our analysis reports. That is called it as inferential statistics. So next slide. Here, so use the data to provide description of the population of the sample, either through the numerical calculation of the gaps of table, that is a descriptive statistics. So inferential statistics makes inferences and prediction about a population based on the sample only. So population entire population is descriptive statistics. Only that sample of the data we can do the population, that is inferential statistics. So next, descriptive study, we can see this descriptive statistics. The next slide, sir. Yes. So descriptive statistics, that is called as we can have a categorical variable, numerical variable, and central tendency dispersion. These are the statistical terms we can going to calculate by using the JAMOVI tool. First one is frequencies, relative frequencies, cross tabulation. These are coming under the categorical variables. The numeric variables, we can calculate central tendency, then dispersion, skewness, and kurtosis. So these are the statistical terms we can calculate. Then central tendency, we can, from the central tendency, we know that the basic statistical values, we can calculate the mean, median, and mode without writing any formula. We just click on the data, we just click on central tendency, it will automatically calculate all the terms of your basic statistics values of a mean, median, and mode. So dispersion, it gives you our range, the interquartile range and variance, covariance, everything it will give. So these are the summary statistics values we can calculate by using the JAMOVI tool. Categorical variable, numerical variable, central tendency, and dispersion. So range, interquartile range, and variance. So next slide. So So central tendency, we know that the mean of the variable can be computed as the sum of the observed variable divided by the number of observations. So median is the midpoint of the variable, the center of the data. A mode is frequently occurring the data. How many number of times the data is frequently highly occurred. So the mode is called it as the most frequently occurring value in the data set. So measure that indicate approximate center of the data are called as measure of central tendency. So measure of central tendency are mean, median, and mode. Mean we know that is the average value of the data sets. So median is center data. Then mode is how many number of times the most frequently the data can be occurred in the data set. That is called as central tendency. Next is dispersion. Next slide, sir. So we can find the range. Simply the difference between the largest value and the smallest value, that is the range. The interquartile ranges. So for example, see this graph. I can have a maximum value and minimum value. From this, I can find out the quarter values. That is the Q1, then Q3, then Q2. So this is the median values. From this value, I can take this value, I can do the statistics, that is called as intercept quartile range. We can plot the graph by using this statistics. That is simply the difference between the upper quartile range and the lower quartile range. That is Q1 and Q3 is upper quartile, Q1 is lower quartile. This that is the center of the Q3 and Q1 is median, that is Q2. We can find this dispersion by using interquartile range. We can do the statistics. So variation and variance and standard deviation we can calculate by clicking on this variable value. Simply I can click variance, means it calculates the variance of the entire data sets. We also calculated the square root of the variance is called as standard deviation. We know that we studied in statistics, basic statistics. That is standard deviation. So measures that describes the spread of the data from central tendency are called as measures of dispersions. The skewness, next slide, sir. So that is graphical representation of our data normalization. That is normal distribution, positively skewed and negatively skewed. We can generate the graph, these type of graphs, and we can find where is the mean appears, where is the median, where is the central tendency. The terms mean, median, mode is occur, where it can automatically represent your graph by working on that JAMOVI tool. So skewness is a measure of symmetry, or more precisely, the lack of symmetry. So first is graph shows this normal distribution of your entire data. Second is positively skewed data and negatively skewed data. Okay. Next slide, sir. So kurtosis chart, you can generate the kurtosis statistic chart. So it has three types: the leptokurtic and mesokritic and platykurtic. So these are these statistical terms we can generate by using kurtosis chart. It's a statistical measure used to describe the degree to which observation clusters, the tails or the peak of the frequency distribution, how it is distributed on your entire data sets, the data values. So leptokurtic means your frequency distribution is a very high. So platykurtic means your frequency distribution is low. So mesokritic means it is the medium. So high, medium, and low. How your frequency of data is distributed in your entire data set. This measurement is called as what is that? I can summarize the statistics what we have seen in this last half an hour. Karthik sir, next slide, sir. So the types of variables I have classified as scaling variables and categorical variable. Next slide, sir. So the categorical is classified into nominal and ordinal. That is mode and median is coming under nominal and ordinal. Then skewed data, the normally distributed data comes under the scale mean is comes under the standard deviations and normally distributed. So data visualization. So this is next slide, sir. So here we can presenting of the data by using the visualization tools as a graphs. So these are some various graphs we can going to use in generate. So basics of the charts we know already, but once again I have to recall to you the types of charts. Next slide, sir. So we know the charts: bar chart, pie chart, scattered plot chart. The second one is scattered plot chart. The interquartile range chart. These are the different types of charts we can generate by using the JAMOVI. Next, pie chart. We know that the pie chart is the circle representation of the charts. Next is bar chart. Next slide, sir. Next slide, sir. Next pie chart. Next bar chart. So we can generate the bar charts of giving that horizontal and vertical values. Next is histogram. Scatter plots of two different variables. So box whisker plot, that is the interquartile range chart. Next slide. This is the box whisker plot. So you can show you have a maximum value, minimum value, the interquartile, upper quartile, lower quartile, the median values. You can do the statistics on this pink colored there is the statistics. So next, which chart we can use for this? For example, next slide, sir. You have only one variable. That is the scalar data. That is will be a histogram chart. The next is categorical variable. It's only one variable. You can do that bar chart. Then scale that your data is scale two scalar data. So you can go with scattered plot. One scalar data, one categorical data. That is a box plot. The both are categorical. You can go with multiple and stacked chart. Okay. So this is the chart we can generate based on the variable values. The variables only classified into scalar type and categorical type. So if both are, the two are scalar variable, you can go with scatter plot. Only one variable means you can go with histogram, sorry. And scale and categorical and scale, that will be a box plot, a boxer plot, that is an interquartile range chart. So both are categorical variable means you can go with multiple and stacked chart. So gender, male and female, you can go with bar chart. So restaurant feedback, a very bad. Next slide, sir. So if you are taking a gender means you can using next slide, sir. Karthik sir, next slide, please. Yeah. So gender, the male and female, you can have a pie chart. So with restaurant feedback, a very bad, neutral, and good, and very good. You can go with histogram. So billing amount per purchase at Amazon, you can go with bar chart. So based on this, your data set, you can find out your chart and you can generate your charts. So later we will see this data analysis techniques while doing. So next slide, sir. Next slide. Data analysis techniques, the univariant, bivariant, and multivariant. So these are the data analysis techniques we will do in JAMOVI. So in the next sessions, in the next 4 day sessions, we will complete everything. So univariant and bivariant and the multivariant, everything we will do by using a JAMOVI tool. So today we can wind up the session. Tomorrow, dear participants, kindly listen. Tomorrow I will show you how to install and download, and install the R programming environment on your computer systems and JAMOVI. Then how to working on that JAMOVI basic statistics on JAMOVI tool. Thank you.
Thank you, sir. Sir, dear participants, if you have any question, you can ask now. Or post your questions in chat box or Q&A session.
Participants, please post your questions. If you have any question, kindly post it on the chat box.
Okay, sir. Thank you, sir. Thank you so much,
Okay.
sir. Sir, shall
Okay.
you wind up, sir? Fine,
Okay,
thank you,
sir.
sir.
Okay, sir. Thank you.
So, Shasha, dear participant, session will start at the same time on tomorrow. So, feedback link has been posted in the chat box. Kindly fill the feedback form by 1:30 p.m. Thank you.
Thank you, sir.